Writing function rules. The question that we need to ask ourselves over and over as we are writing function rules is, what must I do to the x value to get the y value? Our key concept: when x equals 0, the y value is the constant in the rule. The constant is helpful in finding the pattern that is the function rule. Writing a function rule from a table. So we are given a set of data. We have our x values and our function of x values, or f of x values, or our input and output, or our domain and range. So we have 1, 1, 3, 9, 6, 36, 9, and 81. So I need to start asking myself, what can I do to 3 to get 9? And what can I also do to 6 to get 36? Now, I might look at this to start with, and I might start thinking that, well, I multiply this x value by 3 to get 9. So does that work for everything? If I multiply every x value by 3, will I get the output value? 6 times 3 is not 36. So I know it's not just multiplying by 3. So what I should start to recognize is that the x value is actually being multiplied by itself. 1 times 1 equals 1, 3 times 3 equals 9, 6 times 6 equals 36, 9 times 9 equals 81. So x times x is the function rule. We can also write that as x squared. And the function rule is written as f of x equals x squared. And it's really important to check that this works for all of the data points in your table, which we just did. The second example, we have our x values and our y values. 1, 3, 2, 6, 3, 9, 4, and 12. So I need to start looking for patterns and relationships between the input value and the output value, or the x value and the y value. So if I look at my first set of data points, 1 and 3, I might start to think, well, maybe I'm just adding 2 to the x value. 1 plus 2 equals 3. But does that work for all of the examples? 2 plus 2 does not equal 6. So I need to rethink and come up with something that works for all of the data points. So what can I do to 1 to get 3 that I can also do to 2 to get 6? Well, pretty simple. I can multiply the x value by 3 and it will give me the output value. So the x value is being multiplied by 3. So our function rule is y equals 3x. But I need to check that this works for all the data points. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. It works for all my data points, so I have my function rule. The third example, my x values and y values, I have -2, -6, -1, -5, 0, -4, 1, and -3. And I've highlighted this 0 because remember at the beginning our key concept was when x equals 0, the y value becomes the constant in the function rule. And that's really helpful for finding our function rule and the pattern that is our function rule. So the only thing that I can do to 0 to get -4 is subtract 4. I can't multiply 0 by anything to get -4. So the only thing that I can do to 0 to get -4 is subtract 4. So if I have x minus 4, and when we say x, we're really saying 1x, we're multiplying it by 1, x minus 4, let's check if that works for all of our data points. -2 subtract 4 is -6. -1 subtract 4 is -5. 0 subtract 4 is -4. 1 subtract 4 is -3. It works for all my data points, so I have my function rule. The fourth example, x values and y values, 0, 1, 1, -4, 2, -9, 3, -14. So 0 again is in the table. So this y value that corresponds with our 0x value is going to be really helpful in determining our function rule. So that's what we're going to use to start our pattern. The only thing that I can do to 0 to get +1 is to add 1. So I know that plus 1 is going to be the constant in my function rule. But if I add 1 to the other x values, let's see if it works for the corresponding y values. If I have 1 plus 1, it doesn't give me -4. So I'm going to need to rethink it a little. So something is being done to these x values before I'm adding this 1. So let's have a think. And when we're trying to come up with our function rule, we can use this constant, this plus 1. We can use that to work backwards to help us find our function rule. So if we're working backwards, instead of adding 1, we're going to subtract 1. So -1 subtract 1, -4 subtract 1 is -5. Well, what can I do to 1 to get -5? -9 subtract 1, remember we're working backwards, so I'm doing the opposite. -9 subtract 1 is -10. So what can I do to 2 to get -10? And it will be the same as what I can do to 1 to get -5. Again, working backwards, -14 subtract 1 gives us -15. So now I'm looking at a relationship between 3 and -15, 2 and -10, 1 and -5. So when I think about it, what I'm doing is I'm multiplying my x value by -5, and then I'm adding 1 to get my y value. So let's try that out. 1 times -5 is -5. -5 plus 1 gives me -4. 2 times -5 gives me -10. -10 plus 1 gives me -9. 3 times -5 gives me -15. -15 plus 1 gives me -14. So my function rule for this set of data is y equals -5x plus 1. Writing a function rule from word problems. Suppose you borrow money from a relative to buy a lawnmower that costs $245. You charge $18 to mow a lawn. Write a rule to describe your profit as a function of the number of lawns mowed. So the first thing that we need to do when we're writing a function rule, especially if we're working with a word problem, is we need to define our variables. And we don't just need to come up with a letter for them, but we need to define what they stand for, what they represent. So I'm going to use n to represent the number of lawns mowed, and I know that that's something that I need because my word problem asked me to write a rule to describe your profit as a function of the number of lawns mowed. So the other variable that I'm going to define is my profit. And I've been asked to write it as a function of the number of lawns mowed. So it's going to be profit of n. So n being the number of lawns mowed, p of n being the total profit. So what I'm going to do is going to think about, in words, what am I trying to say here in terms of writing a function of the number of lawns mowed to represent my profit. So what I'm saying is that my profit is $18 for each lawn that I mow. But the other thing that I need to consider in writing my function rule is that I've borrowed some money. I've borrowed $245, which I'm going to need to pay back. So that doesn't count towards my profit. So what I need to do is I need to subtract $245 from the money that I make from mowing the lawns at $18 each. So my profit is $18 for each lawn mowed minus the cost of the mower. So my equation becomes P of n, which stands for total profit. P of n equals 18 times n, $18 for each lawn mowed, the number of lawns mowed, minus 245 because I borrowed $245. So I need to subtract that from any money that I make because I need to pay it back. So my equation is P of n equals 18n minus 245.